Okay, so we're in 7.2, the second part of it today. So today we're going to talk about the washer method. We did the disc, and I'm going to go back to my picture for the disc. Okay, my disc was a disc, a bunch of discs together, right?
Yep.
So now the washer method, we're going to take a hole out of the middle. So we have a hole. A washer has a hole. So what we need, if you notice, if we were to find the volume, we would need a top. And when we would need the bottom, and you would get everything in between them, wouldn't you?
Yeah.
But this time we're rotating it. So we're going to have the volume of the washer. You need this. Mm-hmm. Volume of a washer would be pi r squared minus lowercase r squared times the width. That's what it would be. So lowercase r is going to be your distance from your axis of revolution. Uppercase R is going to be the top, like the total distance. Mm-hmm. Is that making sense?
Yep.
Sadie, is that making sense?
Sure.
Oh, no.
No, it's not. I'm just.
Okay. So I'll repeat what I'm saying. Uppercase R is the total distance. So from the top of the object to the axis of revolution. That is capital R. Okay. Lowercase r is this area in between the object and the axis of revolution. That void area. That would be the center. Does that make sense now? Mm-hmm. Okay. So in our picture down here, our capital R is the distance from the axis of revolution to the top. And the width is obviously the width. So what we have then is the washer method volume is right here. Yes.
So do you remember our integral sheet?
Yes.
Could we put these down? Because they're bottom integrals, or?
Yes, you can put both the disc and the washer method down on the sheet. You probably won't need to be revamping them again, so they're more organized and condensed.
Okay.
So to me, every couple of things I added to it, I always rewrite it so I can reorganize it in my brain, and it also helps you remember it better.
Okay.
So the washer method says pi, and we're pi because we're a circle, right? Mm-hmm. The integral from A to B, and if you look down at here, this picture here, it gives you your A to B. It's just your distance of capital R squared minus lowercase r squared dx. So we just have a couple different pictures of what we're actually looking at and rotating and finding the volume of. So we could do examples forever and a day, but I don't know if they're quite useful. So here's our example. So this is a cross section. The top picture is a cross section. And if I would rotate it about the x-axis, it would look like the picture on the bottom.
Is your screen full?
I'll have it freezes and then I just go on and it goes unfreeze. Okay, so the top is a cross section. This cross section right here.
Uh-huh.
And then I rotate it about the x-axis, and this is the shape that it would form. So you have to know when the disc method would be useful and when the washer method would be useful. The washer is when there is a hole in the center. Do I have a hole in the center?
Yeah.
Yeah. Okay. So find the volume of the solid form by revolving the region bounded by the graph of y equals the square root of x and y equals x squared about the x-axis. So again, we need to find out where these two things intersect. How do I do that? Set them what?
Equal to
each other. So I would have the square root of x equals x squared okay, and so I would need to, this looks really weird, I'm trying to think how I'd make this easier. Could I square both sides?
Yeah.
Would that work? So if I square both sides, I would have x equals x to the fourth.
Mm-hmm.
So then set it equal to 0. So I have x to the fourth minus x equals 0. So then I factor out an x. So I have x cubed minus 1 equals 0. And I set both of those things equal to what?
To 0.
To 0. Okay, do that. How do I answer this?
Oh, you want us to...
Yeah. So x equals what?
0 and 1.
0 and 1. Okay, so my a and b are 0, 1.
Yep.
Okay, so this is a and b. Because they didn't tell me a, b, so I have to find where they intersect.
Okay.
Okay, so now I need which function is on top. Looking at your picture, what function is on top?
1, 1.
No, what function is on top?
Y equals square root of x.
Okay, so y equals square root of x is going to get everything down here. Yes?
Yeah.
Okay, so then what function is underneath?
Y equals x squared.
Y equals x squared. Shouldn't have picked blue. So that's going to get everything where? Down here.
Mm-hmm.
So we can get rid of that. Okay, so we have volume equals pi, the integral from a to b of capital R x squared minus r lowercase r x squared dx. Correct?
Mm-hmm.
Did I write that right?
Mm-hmm.
Okay, so I need to plug it in. So v equals pi, integral from what to what?
0 to 1.
0 to 1. Capital R is,
Square root of x.
so square root of x
Mm-hmm. Squared.
squared minus,
X squared.
so
Squared.
x squared squared. And I would encourage you to write the formula. You're going to have it on your sheet, but the more you're familiar with it, it's easier it is going to be to work with. Okay, so then I got to square things, right?
Mm-hmm.
So I have the integral from 0 to 1 of x minus x to the fourth.
Yep.
So that's pi. The integral of x is
Half x squared.
1/2 x squared. And the integral of x to the fourth is
1/5 x fifth.
from 0 to 1. Now, you guys keep going down. I have to go up here. Okay, so I still have pi, right?
Mm-hmm.
And I need to plug in the top. So I have 1/2 times 1 squared would be 1/2, right?
Yeah.
Minus
1/5.
1/5. Minus, and then I plug in 0 and I get what?
0 for both of them.
0 for both of them, so minus 0.
Yep.
So common denominator,
10.
10.
Yep.
So we have v equals pi times 5 minus 2 over 10.
So it'd be 3 over 10.
So volume equals 3 pi over 10. And units cubed if they don't give us any units. And that's basically it. Bless you. So when I'm doing this problem, I'm doing what we did in section 7.1. I just told you it is the disc method now, or it is the washer method. So again, how are we going to decide whether we do the disc method or the washer method?
If it has a hole.
If it has a hole, it's a disc. If it's solid,
It's the washer.
like this is solid. Wait,
Yep.
no, we said that wrong. As a hole, it's a washer. We said it
Oh,
backwards.
yeah.
Hole, it's a washer. This is solid
disc.
is a disc. This whole thing is solid as a disc.
Yep.
But if I said this thing right here, if I said rotate that,
Yeah.
that would be a washer, correct?
Yeah.
Because you'd have this big void.
Yeah.
Make sense?
Makes sense.
Okay, so yesterday, your homework, and I did post it in classroom, didn't I? I'm pretty sure.
Yeah.
So yesterday, your homework was 7.2, page 465, 1 through 14, wasn't it?
Yeah.
And today it's 7.2. And I think I said Monday and Tuesday on this in classroom.
Yeah.
So today, I know it's Tuesday, but we need some washers. So,
Can you only add like one?
add one. Well, I want to make sure we're getting some washers. How about I give you guys give me a minute to look this up? Because if you look at the assignment, I'm going to show you number 9, what it looks like.
Okay.
So if I give you number 9, and this is 9, and I say this, okay? This is my picture right here.
Yeah.
So it's this area. And I tell you which it does to revolve it around the y-axis. That's a solid shape, correct?
Yeah.
So that would be the disc. So this would be disc. But what if I ask you to revolve it around the x-axis?
It'd be washer.
It'd be washer because you have all this empty space.
Yeah.
So this would be washer. So what I might do for our assignment here for washer method is tell you to revolve around the other axis. Does that make sense?
So basically just say which one's disc and which one's washer.
Right. So if I do, the problem on 9 tells me the y-axis. So that's disc.
Yeah.
But if I tell you the x-axis, that would be what?
The washer.
Washer. So you could do both methods, and should you get the same volume?
Maybe.
I don't know, we'd have to see. Because this volume would be this solid shape, wouldn't it?
Yeah.
It'd be this solid shape.
Mm-hmm.
But this one would be... Can't draw.
What?
My brain went backwards. Let me get it right. So this shape would be like this.
Mm-hmm.
Like this.
Mm-hmm.
But you'd have this. Do I need to have a, there. We'd have all this that exists on the outside, but not on the inside.
Yeah.
Right? I can't draw 3-dimensional. So you might have the same, and you might not have the same. Probably, I'm guessing you don't have the same. Because on the top one, do I have a hole in the middle? No. This is a solid shape. Down here, I have a hole in the middle. So probably not having the same volume, huh? So I will put this assignment up.
Okay.
But yesterday's assignment is yesterday and today.
Okay.
Got me?